So what is it we need to know? This. I need to know. Do I know everything else in that equation? If so, algebra comes in and saves my ass. Do I know this? Yeah, what is it? 0.2. Do I know this? Yeah, from the beginning. I don't know this. So that's like my x now, right? That's like my x in algebra. Minus, and what's this? We just figured that out. Hopefully I thought about this correctly. No, I didn't. Oh well. It's too bad for Jeff. Let me. It's hard to think this far ahead. Let's see. So it's got to be, so we go back in time, change this to 0.5. Now it will work. Because what do you do now? How do you get the probability of V? You just, and this is where I really see who took algebra like a long time ago, or maybe should not have passed it or something. This is not very extensive algebra. This is basically around the highest level of algebra you'll see pop up every now and again, but there will be some algebra. So of course, how do I do this? Subtract 0.7, add 0.35, 11. So 0.5 plus 0.35 is 0.85. Minus 0.7 is 0.15. All right. So that's just an example of, and I notice the numbers aren't quite going to work out for me for later, but that's an example of the kind of problem where you actually have to use the formulas. I just give you numbers for these. I don't tell you any, I just give you values for the probabilities. I don't give you a situation where you can count everything.
Although it is over 100%.
I know. That's why I'm not going on. I'm making these numbers up on the fly. I have no idea. Okay. So one last idea for today. This is kind of a big one. Let's see. Aw. I want to look closer at this thing here. So, something interesting to notice about and is it's got a multiplication in there. What did we say about or versus and? Which one makes things bigger? Which one lets more people in? The or. And makes things smaller. Now, part of your brain might have said, if and is equal to some multiplication of two things, why does that lead to smaller stuff? Because when I multiply things that are less than 1, so what is, because normally if I just multiply numbers, do they become bigger or smaller? Bigger. But if what's 0.2 times 0.4? 0.08, right? If you multiply two things that are less than 1, the answer is less. I like it. So and is multiplication makes sense because all these probabilities are less than 1. Now here's another reason why this multiplication makes sense. I have two examples. One of them is silly, and one of them is much more serious. It involved young Jeff crying in English class. Because let's start with the serious one. So I used to live in Florida, right? There's no crime report involving me, thankfully, but almost everybody. Yeah. And we would go out to watch the space shuttle take off. I can actually see it, and sometimes you can even see the booster falling. It was crazy. But for some reason, that day we didn't go. This is 1986. I don't know if anybody knows this date. You guys are like, that's before I was born. But stuff still happened. What happened in 1986 related to the space shuttle? Yeah, unfortunately, I have to now say the first time that the shuttle blew up was in 86. We didn't go out that day for whatever reason. And then in English class, they announced that it had blown up. And little Jeff, all about space, just started crying. I was just gone, right? I'm like, and then later I'm like, thank God we didn't go out and watch it or something, and just anyway. Does anyone know anything about why it blew up? Yes. No, you're thinking about the Mars. Which Mars thing? The Mars Climate Observer? No. One of those Mars things. One group used metric and one group used our stupid units. And the thing smashed into Mars because we didn't have it. That was hilarious. Okay, we're all, what? Oh shit. We used feet. I don't know if you guys know about that. Anyway, sorry. We're the one country left on the face of the earth that doesn't use metric. Because we're American. Anyway. Sorry. But no. It was because of this. You ready? It was because along the fuel line, there was this thing called O-rings. They were valves. They made sure that the fuel went in one direction. Because if the fuel goes the wrong direction, that's bad. Now that morning, it was cold. It was icy. Like the ice on the windshields, right? The frost. So these weren't working correctly. But let's say that normally an O-ring fails like 1% of the time. So why would you want multiple O-rings then? If I have another O-ring and it has a 1% failure rate, it wouldn't make any sense to add those to see the total failure rate. Are you guys with me? It's sort of like, does anybody do this? If you have a huge final exam, do you set more than one kind of alarm? Has anyone ever done that? Yeah. None of you. Oh shit. You're like, no dude, I want to not wake up so I can take a leave. Dude, my alarm, screw you. Just set 2 freaking alarms. Why would you do that? If you live in a bad part of town, your door might have many locks. So why do we do these things? So the door having many locks, you want to decrease the probability that somebody successfully breaks in. All right, you can pick this kind of lock. What about this kind of lock? Or if you can do them all, I at least want to make it take you time so I can hear you call the police and they come, right? I just want to give one big lock and you're in. No. You guys with me? It's a contingency plans. The alarm thing. The probability that both alarms don't work is very low. You don't add their probabilities of failing. You multiply. So 1% of the time this would fail. And 1% of those times this would also fail. So it's 1% of 1%. And dear God, what does of mean? In math, what does of mean? Times. It makes me really sad that high school is failing you. So few people know what of means anymore. It kind of sounds like Bill Clinton. Depends on your definition of is. But of, there we go, some historians. Of means multiply. And what's 0.01 times 0.01? Yeah, 0.0001. Which is 1 out of tens, hundreds, thousands, tenths. So 1 out of 10,000 times they would both fail. And of course there were more than 2, right? Let's just say 2. So what happened on that morning is they were both iced over, and so their probability of failing shot way up. I don't know the numbers, to be honest. You guys kind of with me a little bit? Okay. But that's a beautiful example of the same idea as multiple locks or multiple alarms or whatever, right? Here's the silly example. So let's say I want to join a fraternity. I always say sorority by accident. Say I want to join a fraternity, right? I'm like Will Ferrell trying to live my stuff over again. And I have to do some light hazing. Not hazing that would make the news, just some very light hazing. I got to walk down this long hallway In every third step, somebody slaps me in this cheek. Ouch. In every fifth step, somebody slaps me on this cheek, right? So what's the probability I get slapped on this cheek? Every third step. 1 out of 3, right? And every fifth step, so that's 1 out of 5. How often will I get slapped at the same time on both sides of my face? Every how many steps? You can do it. 15. Every 15 steps. And what is 1/3 times 1/5? 1/15. So the probability that I get slapped this cheek and this cheek is the multiplication of those two things. So there's examples of why the algebra we did to arrive at this matches with the idea of what should happen. That's beautiful. That always frickin' happens, but it's nice to see it happen. I love it. Maybe. Okay, so the main place that this idea comes into play is when you have multiple things, more than just one thing to look at. So for example, I'm going to assume that somebody in here is not the best with cards, because it's almost always true and people don't want to speak up, right? I know most of you probably know how many suits are in a deck of cards and all that kind of stuff, but some of us might not. So let me set up a classical problem here. Let's say I have, well, it can be all color coordinated too. 11 blue poker chips, 5 green poker chips, and 2 red poker chips, and a bag, right? A classic probability question. So let's just start off with some ground rules here. If I pick one chip, what's the probability I pick a blue chip?
11 out of 18.
11 out of 18. Why? Which is whatever the hell it is. Actually, what is it? Stay with me now. Six one one one. Neato. All right. And what's the probability I pick a red or a green?
16.
A red or a green?
Yes, 7.
Yeah. 7 out of 18. I like it. And then that's 0.3. What would that be, Jeff? 0.3. What is it? 0.3889? Okay. All right. Now, here's where things get more interesting. If I pick 2 poker chips, but I do it in a certain way, there are 2 ways I can do it. I could pick one, plop it back in, and then pick one. So I could pick the same one again, right? Or I could pick one, feed it to my little brother, and then pick another one after that. Those are 2 very different situations. They're not going to have the same answer. Let's do the simpler one first. We call this method with replacement, which makes sense. I replace the one I picked. So I'm picking 2 chips. So let's say I want to know what's the probability I pick a blue chip and then a green chip. And we know what and means. Or basically means add. And basically means... What does and mean? Bam, bam, O-rings, right? Explosion. What does and mean? Multiplication. I love it. Or means add. And means multiply. Very basic level. So, I'm going to pick a blue chip and a green chip. So sort of like hangman game in math. What's the probability that that first chip is blue? 11 out of 18. I drop it back in. Why is it important that if I drop it back in? Because what stays the same now? The denominator. So what's the probability that the next chip is green? Yeah, 5 out of 18. And then you just multiply that stuff together. Yes?
How do you know it's a good
It has to say, yeah. I have to say in the instructions. I'll say with replacement, and then the next set of questions will be without replacement. And I have to say it. Otherwise, you're like, okay, how are you doing this, Jeff? What is that, real quick? I love you guys.
0.1698.
So I mean, basically, I could now watch just to kind of level this up a bit. What if I picked 4 chips with replacement? And I want to know the probability I get a red, and then a blue, and then a green, and then another red. I mean, how would you do that? How many blank spots do you have? 4. And they're all separated by what operation? What operation? Multiplication. So it's the same idea. You just make how many spots related to how many things you're doing. And it's and, so you're going to multiply. So you got a red one, so that'll be 2 out of 18, times the blue one's probably stays the same because they dropped the red one back in. The green one, and then times again 2 out of 18. And you know, whatever the hell that is. 16 over 81. 1/5. 0.002? I don't know. I'm reaching. Anybody gonna help me? I can't.
0.0021.
Ooh! Sorry, come on. It's my one skill. Come on. And you're like, okay, math boy. Okay, alright, I like it. Now, let's try some without replacement. And then I'll let you guys try some, and then we'll call it an early day. Okay. Let me see, where am I at? So let's do pick 2 chips without, get out of there, replace it. Find the probability that I get a blue and then a green. We'll do that same one again. So there's still going to be, I want blue and then a green. What's the probability that first chip is blue?
11 out of 18.
Still 11 out of 18. But what happens now? Right, feed it to my little brother. Just throw it away, whatever.
Oh, 5 out of 17.
So now the bottom is 17, but why is the top still 5? Because it wasn't a green chip I got, right? It was a blue chip I threw away. So when you have without replacement, at least the bottom is going to change. Because you're losing 1. Now the big mistake I see is somebody puts a 16 here. What are they thinking? They're thinking they're picking 2. Yes, ma'am?
Can you just explain that again?
Yeah. So at this point, how many chips have I picked? This represents what? What's 11 out of 18 represent? It represents a blue chip. So I've picked 1 chip. And then I throw it away. How many chips are in the back? 17. I like it. Because this is 1 chip. So I lose it. I lose 1 blue chip. So now I've got 17 chips, and I still have all 5 green ones. I didn't throw one of those away. Yes?
Would the odds just double if you decided it was acceptable to draw them in any order?
Exactly. That's coming later. So I'm being very, very specific about the order. The next chapter we're going to get into, well, what if we accept any order? It's a little more interesting. Okay. And then whatever the hell that is. I don't know. I have no idea.
1797.
1797? Okay. All right. So let's see. What about this? Let's probably get a red and then another red. And this is still without replacing.
You take into consideration we already took out blue and green chip or not?
No. Whole separate problem. 11. So on a quiz or a test, every time I have A, B, C. They don't build on each other. They are separate situations. It resets. I'm glad you said that because always somebody's doing some this and this and holy shit no. So first one being read would be 18. The second one being read 1 out of 17, 11. Why? You lost a chip, so the bottom goes down. You lost a red one, so the top goes down. Now, if I said 3 reds, what would that be? You don't even have to do any work. 0. There's no way you can get 3 reds. There's only 2 in the frickin' bag, right? I like it. So let's see. This will be something.
0065.
Oop. Get out of there. I like it. Yes.
What if there's 2 reds at the same time?
Oh, that really is what this means. If I go reach in and take 2 at the same time, that is like this. I like it. Because what does this situation mean? I could pick the exact same chip again. So if I go reach in and I don't take 1, I take 2. That's this. Because there's no way I could pick the same chip twice. Does that make sense? It's a really good point because that seems to be a totally different situation, but it's just this one. I like it. Yes?
So for the first one, you would do green and green. Then on the second number, you would have had
Where am I at? Where?
the I example.
This one. Yeah, blue.
Or we can do blue and blue, right?
Oh, you want another example, a separate
Yeah.
example. Okay, so if I did probably a blue and then blue. Okay, what's the probably that the first one's blue? 11 out of 18. Throw that one away. So I lost a chip. That makes the bottom 17. And I lost a blue chip. So it makes the top 10. So what's the only time that the top is also going to change is if these are the same. Because by this pick, you've lost one of him. By this pick, you lost. Here, I didn't lose a green. I lost a blue. That's why it's still 5. I like it. I like it. This isn't that crazy hard, but it definitely is different than stuff you've done before. Okay, so let me see. Oh, yeah, what was this real quick? Cool. I like it. So let me make a different situation, ask you some questions. We'll go over it, and then we'll call it a day. Let's say I've got... Yeah, I'm going to use this example, and I'll just change it. All right, let's say I've got this haunted house, and I put into the haunted house 11 Republicans, 10 Democrats, and 3 independents. Do you know how many parties there are?
Countless.
Yeah, basically. There's like 50-something main parties.
Registered.
And then every day, there's, yeah, exactly. And then there's just other fringe parties. There's very localized parties. It's insane. So, like the governor, last time we had a governor election for California, you know how many people ran for it? Like 100 and something.
20-something on the ballot, I think.
Yeah, exactly. But there were some local names and some write-ins and some other campaigns, and they were all tied to their own political parties. Like the Whig Party still exists. There's a Communist Party in America. It's insane. But we only hear about the big 3. Sometimes green comes in, right?
Fully succeed. McCarthy didn't fully succeed.
Well, all right, let's not devolve into a political class. I don't want to go there. So if I pick 2 people with replacement, so let come out of this haunted house. I'm going to take them out of here. What's probably I pick a Republican and then a Democrat. And what's probably I pick a independent and then another independent. Then I'm going to ask you the exact same questions without replacement. Exactly the same questions. All right, so try those 4 problems out.
There he is. Okay.